All right, let's look at substitution, and we it's helpful to follow this organizer. Um, Substitution is required when we have a composite function, so there's a function inside of another functions, and with substitution we will let u be the inside function. Du is 2x dx. So we want to find these differentials, and we can substitute for dx, and we can substitute for the inside. This is not applicable, and it's not applicable here. This is when we have a definite integral, and we'll just see one of these at the end. So that's u cubed. U is x squared minus 9, so that's u cubed. 2x, let's just see, that's going to cancel on its own when we substitute for dx. Dx is du over 2x. And these cancel, so now we have a simple function, and we can do the antiderivative. Substitute. U is x squared minus 9. And we can just leave it like that. Okay. Pause the video and try that one. We have an inside and an outside, so let u equal the inside. Du is negative 4x dx. We need to substitute for dx, so we have to divide by negative 4x. And now we can substitute for dx. Let's write this. This is u to the 1/3 power, and then leave that for now, and dx is du over negative 4x. So these cancel, and we just have the integral of u to the 1/3 du. So that'll be u to the 4/3 over 4/3 plus c. And that's from adding 1 to the 1/3. Dividing by a fraction is multiplying by its reciprocal. So now we have u is 1 minus 2x squared. So now we put in 1 minus 2x squared and to the 4/3 power. 4/3 power. Okay, so when we learn substitution, sometimes we always want to use it, but we shouldn't always use it. When there's one term in the denominator, you can just break this up into two separate integrals. So we have t over t to the 1/2 plus 2t squared over t to the 1/2. So we can simplify this so that we don't need to use substitution. This is 1 minus 1/2 is 1/2. Here we have 2 minus 1/2, that's 4, minus 1 is 3. So that's 2 times t to the 3/2. Add 1, 3/2 over 3/2. Add 1, which means add 2 over 2, that's 5 over 2. 5 over 2 plus c. So we have 2/3 t to the 3/2 And this will be 4/5 t to the 5/2 plus c, multiplying by 2/5. 2 times 2/5 is 4/5. Alright, pause the video and try that one. So we have t squared over t to the 1/2, 4 over t to the 1/2. This is 4 over 2 minus 1 over 2 is 3 over 2. And here we have 4t to the negative 1/2. Add 1, 5 over 2. Add 1 to that, and we get 1/2. Two-fifths t to the 5/2, multiplied by the reciprocal, and we get 8 t to the 1/2 plus c. Okay, let's try this one. So here we have to identify the inside function, and there it is, 6x. So we have u equals 6x, du equals 6 dx, and now we have cosine of u du over 6. And that'll just be 1/6. Antiderivative of cosine is sine. So we have 1/6 sine 6x plus c. Alright, pause the video and try this one. The inside is x squared. So we have du over 2x is dx. U is x squared. Dx is du over 2x. So the x's cancel, and we're left with a 1/2. Sine u du, and the antiderivative of sine is negative cosine u plus c, and u is x squared. Alright, sometimes maybe it's less obvious what u should equal, but I think if you remember that cosine cubed is that. So sometimes when it's unclear what u should be, then you just try one and see if it works. So pause the video and try this one. So if we have cosine being the inside, cubed is the outside, we have u equals cosine. du equals negative sine dx. So the differential of x is the differential of u over negative sine x. And now we have sine x over u cubed times dx, which is du over negative sine x. So we just tried one and it turned out to work. So now we have negative u to the negative 3 du. This negative went outside, and then we made that a negative exponent so that now we can use the power rule. Add 1 and divide. Negatives cancel, so we have 1/2. This will be 1 over u squared plus c. Negative exponent puts it in the denominator, and we have 1/2. U was cosine, so now we have 1 over cosine squared plus c. Okay, let's work on definite integrals. Zero to 2 x over radical 1 plus 2x squared dx. U equals x equals u evaluated at some number. Alright, so we look for an inside. Well, the inside could be the whole denominator or just the inside of the radical. Let's try the inside of the radical. Derivative is going to be 4x. And then dx is du over 4x. This is going to be used if the x doesn't cancel. So we just have to substitute and see if there's an x left over, then we can find out what it equals. We do need this now because there are limits. So we want to evaluate u at 2 and u at 0. Here's u. So we have 1 plus 2 times 2 squared. And we get 9. 1 plus 2 times 0 squared, and we get 1. So when we substitute, we'll use these values instead of 0 and 2. Alright, we have x over radical u. Dx is du over 4x. And then we're going to integrate from 1 to 9. The x's cancel, so then we have 1/4. Alright, that's u to the 1/2. It's in the denominator, so we'll make it a negative exponent. U to the 1/2 over 1/2 from 1 to 9. Substitute the 9, so that'll be radical 9. Let's put that 1/2 out in front as a 2 over 1. And then we can just deal with this. So dividing by a half is multiplying by 2 over 1. Just put that out there. Substitute the 9. Substitute the 1. 3 minus 1 is 2. So we have 2 over 4 times 2. 4 over 4, and we get 1. Alright, pause the video and try that one. we see an inside. The differential of u is 2x dx. So dx is du over 2x. We need to find u values instead of x values. So u evaluated at 5 is 27. And u evaluated at 0 is 2. Then we integrate from 2 to 27. X. That'll be u to the 1/3. Dx is du over 2x. So the x's cancel, and we have 1/2. Add 1, so we're adding 3 over 3. We have 4/3 over 4/3. Integrating from 2 to 27. Let's take this out in front as a 3/4. And then we do 27 to the 4/3 minus 2 to the 4/3. The cubed root of 27 is 3. 3 to the 4th is 81. And here we have 3 over 8, 81. Here we're going to have the cubed root of 2 to the 4th. Well, we'll take out a 2, cubed root of 2, and we can just leave it like that. All right, one more. All right, so here we're going to have to use the x equals column. And I want to just pause the video and try it. If you get stuck, then watch the video. So here's our last example. Pause the video and go as far as you can with that. Okay, so the inside function is 1 minus x. We find the differential of u, and the derivative of this is -1 times dx. So dx is negative du. U evaluated at 1 is 0. U evaluated at 0 is 1. So now we're integrating from 1 to 0, x square root of u, and dx is negative du. Alright, nothing is canceling the x, so that means we need to find out what x equals, and x is going to be 1 minus u. So if I move the x over and then subtract u, that's what x equals, and so now we can substitute for x. Put that negative, we just put it out in front, and then the du. We can distribute u to the 1/2. This is a 1, so 1 plus a half is 3/2. Now we do the antiderivative. 1/2 plus 1, 3 over 2, 3 over 2. 3/2 plus 1 is 5 over 2. Substitute the 0, and we have 2/3 0 minus 2/5 0 minus, and then we'll have, substituting the 1, that'll be 2/3 times 1 minus 2/5 times 1. So dividing by 3/2 is the same as multiplying by 2/3. So that's what I did there. We have zeros. Let's be careful of all these negatives. Negative times a negative is a positive. And then we're just going to have 2/3 minus 2/5. All right, and we're going to have 10 15ths minus 6/15. So we get 4/15. And I'll stop there.